Alright, this week we're learning about a type of math and a type of number series called sequences. Now, sequences are just simply a list of numbers in a particular order. This order is going to be determined by the pattern between the numbers. So something that you can think of, instead of thinking of the word sequences, you can think of the word pattern. We're just looking at a pattern of numbers, and we're going to be able to predict the numbers that come next in this sequence or in this pattern. There are two types of patterns that we're going to learn about, two types of sequences. The first one is called arithmetic. Say that out loud to yourself because you're going to say it wrong the first time. Arithmetic. So an arithmetic sequence uses addition or subtraction to have one number go to the next. So we're going to start a pattern. Let's say, for example, we have 5, 10, 15, 20, and the pattern will continue. So I'm going to put the little ellipses right here. It's called an ellipses. Dot, dot, dot. All of your sequences should end with dot, dot, dot because they keep going for forever. But in this pattern, all I'm doing is adding 5 each time. That is called an arithmetic sequence. Plus 5, plus 5, plus 5, on and on. Now, arithmetic sequences have what we call a common difference. The common difference is the pattern that you're using to create this sequence. So for us, the common difference would be 5, because I start with 5 and then I add 5 each time to create the other numbers in the sequence. So my common difference is 5. Now, if you get stuck or get lost and you don't know how to find the common difference, all you need to do is take the second number and subtract away the first number. If it is an arithmetic sequence, then the pattern of first number minus second number will give you the same common difference in between each term. Again, the common difference is just the pattern we're using to create this sequence. On the other hand, a geometric sequence is when we are going to use multiplication or division, or multiplying by fractions, to create our sequence. So for example, let's say again we start with 5, and we do still have 10, but the next number is times 2, 20, is times 2, 40, and on, again with the ellipses because this never ends. This sequence is still a sequence of numbers, or a list of numbers in a certain pattern. Starts with 5, but each time we are multiplying by 2 instead of adding 5. This type of sequence doesn't have a common difference. It's called a common ratio. Common ratio. And in this particular sequence, our common ratio is 2, because each time we're going to be multiplying by 2 to get the next number in the sequence, or the next number in the pattern. Again, just like with the common difference, there's a little shortcut. If you can't look at the sequence and tell me how it's changing each time, multiplying by 2, you can take the second number and divide it by the first number to find your common ratio. So, the too long didn't read. There are two types of sequences. Arithmetic means that your sequence or pattern is going up or down with addition or subtraction and has a common difference, the number it's going up or down by. A geometric sequence is using multiplication or division to find the numbers in the pattern. The common ratio is the number I'm multiplying or dividing by each time to create the sequence. That's the gist of what we're learning today. The first couple examples, what we're going to do is we're going to determine if the sequences that I write on the screen are arithmetic or geometric, and then we're going to find the common difference or common ratio for those. So your first sequence we're going to work on today is 1, 4, 16, 64. There's our first sequence of numbers. If we're looking at this one and thinking that maybe it's arithmetic, we would say, okay, to go from 1 to 4, I have to add 3, which means I would add 3 every time. 1 plus 3 is 4, good. 4 plus 3 is 7. 7 is not what I have next in my list. So this is not an arithmetic sequence, so we try geometric. To get from 1 to 4, I would have to multiply by 4. So 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. If multiplication works, this is called a geometric sequence. It is a geometric sequence. Geometric sequences have common ratios, not common differences. And that number that I said out loud that I would be multiplying each time is 4. So the common ratio for this sequence is 4. It is a geometric sequence because I'm using multiplication. The second sequence to try today is 3, 8, 13, 18, and on and on. Okay, I always suggest trying to see if it's an arithmetic sequence first because it's generally easier. So let's try to add or subtract some numbers. To get from 3 to 8, I'm going to need to add 5 each time. So 3 plus 5 is 8. 8 plus 5 is 13. 13 plus 5 is 18. And if I were to keep going, each time I'd just be adding 5. Since I used addition, that makes this an arithmetic sequence. Arithmetic sequences have common differences, and that common difference that I'm adding each time is 5. Easy. Adding and subtracting is arithmetic, multiplying, dividing is geometric. Then you just have to tell me how the pattern is changing. Let's try another one. How about this one? We have 40, 20, 10, 5, and on and on. If you look at this one and we try to use an arithmetic sequence, to get from 40 to 20, I'd have to subtract 20. So 40 minus 20 is 20. 20 minus 20 is 0, not 10, so that didn't work. We need to try using multiplication or division. How do I get from 40 to 20? We would divide by 2. Let's see if that pattern works every time. So 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. So if it works every time, that's going to be the answer to my sequence. Since I used division, or multiplied by the fraction 1/2, this would be a geometric sequence. Geometric sequences have a common ratio, and in this case, since I'm dividing by 2, it's represented by the fraction 1/2, because I am dividing by 2. Fractions are division, division are fractions. Last example here, let's say I have the sequence 21, 18, 15, 12, and on and on. We start with arithmetic to see if it will work. To go from 21 to 18 using addition or subtraction, I'd have to subtract 3. Let's see if that pattern works every time. 21 minus 3 is 18. 18 minus 3 is 15. 15 minus 3 is 12. That works, I made all the numbers. Since I use subtraction, I'm going to be able to call this arithmetic. Arithmetic sequences have a common difference, and in this case, the number that I'm using each time to create the pattern would be -3, because I'm subtracting 3 each time. You are going to be asked to determine if sequences are arithmetic or geometric. Again, if you get stuck and you cannot figure out if they're arithmetic or geometric, you can always take the first number. Sorry, that's incorrect. You can always take the second number minus the first number to find your common difference, or you can take your second number divided by your first number to find your common ratio. That's the shortcut if you can't look at the numbers and remember what to do. Those are your two patterns to look at. First minus second minus first, or second divided by first. It will give you your common ratio or your common difference. Now, one of the other things we're going to ask you to do is to describe a sequence in many terms and then determine the next four numbers in the sequence. So for example, let's say you have the sequence 5, 20, 80, and 320, and on and on and on. Okay, 5, 20, 80, and 320 are the numbers in this sequence. If we tried to make this arithmetic, the second minus the first, so 20 minus 5 is 15, so we'd be adding 15 each time. 5 plus 15 is 20. 20 plus 15 is 35. That's not the next number in the sequence. We don't think arithmetic works. Let's try geometric. 20 divided by 5, because that's second divided by first. 20 divided by 5 is 4, so we might have a common ratio of 4. 5 times 4 is 20. 20 times 4 is 80. 80 times 4 is 320. That looks pretty good. So here's some things we know. We immediately know that this sequence is geometric, which means that it has a common ratio. We know those things because we used multiplication to get from one number to the next in this sequence, in this pattern. The common ratio itself was 4 because that's the number I multiplied each time. 5 times 4, 20 times 4, 80 times 4, 320. Because each term is multiplied by 4, okay, to create the next term. Here's something we haven't talked about yet, but the word's initial value shouldn't be new to you. But sequences, just like equations and graphs, also have initial values. Initial means the beginning number. So if we look at the beginning number in the sequence, it would be 5. That's my initial value. That's my starting or my 0 spot, my initial value. Now let's predict the next 4 terms in the sequence. So if I were to finish this out a little bit and have more numbers in it, I'd have 5, 20, 80, 320, and then I need 4 more. 1, 2, 3, 4. I'll move my face because you can't see it. There we go. Okay. So we need to fill in these blanks because we need the next 4 numbers in this sequence. Okay. 5 times 4 is 20. 20 times 4 is 80. 80 times 4 is 320. 320 times 4, use your Desmos or your calculator to calculate that is 1,280. 1,280 times 4, to continue the pattern, is 5,120. Multiply it by 4 again to get 20,480. Multiply it by 4 one more time to get 81,920. And on and on and on. I still put the ellipses or the dot 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 at the end of this because this sequence, though we stopped, still continues forever, always multiplying by 4. So you can use Desmos as a calculator to just continually multiply these numbers, or grab your phone calculator out and multiply these numbers by 4 to get this number in the sequence. We're going to do one more example like this type of question. So we're going to describe the sequence and then determine the next 4 numbers in the sequence. The sequence that we're going to be using for this last example is the following. We have -15, -12, -9, -6, and on and on. Like I said at the beginning of the video, it's easier to start assuming that they're all arithmetic and then just make it to geometric if arithmetic doesn't work. So let's try this. The way that I get from -15 to -12 is kind of confusing. So if I use that formula that I wrote down earlier, where it's the second number minus the first number, okay, I'd have -12 minus -15. Minus a negative, y'all know I hate that. Minus a minus is really just plus, so I'm doing -12 plus 15. That's 3. So I'm actually adding 3 each time to create the next numbers in the sequence. Let's see if that works for the entire thing. -15 plus 3 is -12. -12 plus 3 is -9. -9 plus 3, -6, and on and on. Since the positive 3, like adding 3 each time, worked, we are going to be able to call this one arithmetic, because we are able to add numbers each time and it worked. Arithmetic sequences have a common difference, and in this case, that common difference that I'm using each time to create the numbers is 3. Because we are adding each time. We're adding 3 each time. So again, initial value is the first number in the sequence. So in this case, negative 15 would be my initial value, since it's where my sequence begins. And if we wanted to finish the sequence out, add 4 more numbers to the sequence, all we would need to do is continually add 3 to create the next few numbers in the sequence. So let's do it. We've added 3, added 3, added 3. So negative 6 plus 3 is negative 3. Plus 3, 0. Plus 3, 3. Plus 3, 6. And on and on. Again, the ellipses are there because the sequence does keep going. I just wrote out the next 4 numbers in the sequence. That is it, folks. We have 2 types of sequences, either using adding and subtracting for arithmetic to create your numbers in your sequence or your pattern, or we use geometric sequences for multiplication and division. As always, we empower, we impact, we love. We are Skeeter Nation, and we miss you.